This is R.D. Sharma Solution Class 12, Chapter 19. Exercise is 19.28 from Indefinite Integrals. So there are three very important formulas or result. Integration of a square minus x square dx. So this is equal to x by 2 under root a square minus x square plus a square divided by 2 sin inverse x by a plus constant of integration. Now the second formula, you can write it as x square plus a square or also a square plus x square, they both are same. And the result is x by 2 under root x square plus a square by 2 log, and inside the bracket we have x plus under root x square plus a square plus a constant of integration. Now this is very important, under root x square minus a square, and the result is x by 2 under root x square minus a square by 2 log x plus under root x square minus a square plus constant of integration. Now these three are very important, and how they are going to be proved I'll show you in just a bit. Under root a square minus x square, this integral, and the direct result after integrating this is x by 2 under root a square minus a square plus a square by 2 sin inverse x by a plus c. Now the result is okay, but how actually we have got to this result? That is, integration of u dot v, u is the first function, v is the second function. So the result will be u integration of v, that is the integration of v with respect to dx, minus integration of differentiation d by dx of the first function, which is u, and the integration of the second function. Now when you multiply these two, then the result will be dx, that is one more time we'll be integrating it. So we have this under root a square minus x square. So integration of a square minus x square, how are we going to go about it? What are going to be the steps? So you know already that root x is equal to x to the power half, x raised half. So we'll do it by the integration by parts. So we'll assume that 1 is already there. We don't have to assume because 1 is already multiplied by every number. Now we'll take the first function as under root a square minus x square and second function as 1, as I indicated you in integration of u dot v, the formula we are going to use just now. So the first is under root a square minus x square, integration of 1 dx minus integration of now the differentiation of the first function, which is under root a square minus x square, then the integration of 1 dx, and then final multiplication of these two, differentiation and integration, and again the integration. So what do we get? 1 dot dx is x only, integration of 1 is x, and under root a square minus x square is untouched. Now this d by dx of under root a square minus x square that we are going to do. Now under root x differentiation is 1 by twice under root x, you already know that. So we can just write it as, after differentiation, 1 by twice of under root, what is there? A square minus x square. But we need to differentiate a square minus x square also. So when we differentiate a square minus x square, a square is a constant, it will go 0, and negative x square will give you negative 2x. So you can write negative 2x here. How about integration of 1 dx? This will be x only. So let's write x here. Now this x into x, I can just write x square here. It can be written in the next step, but you understood now. So it is x square, x into x. Now we need to integrate this second part. First part is already done. So this 2 will get cancelled, but will not do anything with this negative sign. So negative x square divided by under root a square minus x square, I am explaining it separately. Now you know this a square minus x square is in the denominator. You need a square also in the a square minus x square in the numerator. For that, add a square and subtract a square, and then separate these two terms. A square minus x square is the first term, and second term is negative a square. So x square minus x square divided by under root a square minus x square will take as the first term, and then minus integration of a square divided by under root a square minus x square will be taken as the second term. So this minus, sometimes you are tempted to just take it outside and make it as positive. But here, this is not the case. You need to keep this negative in order to make it a square minus x square like that. Now we need to replace it here, because actually the second part I told you, and there is a negative multiplied. So I'll just multiply negative and then replace it. So when you multiply this negative, the sign will get changed. So we have x under root a square minus x square as the first one, which is already unchanged. And then we have this whole, which I explained you separately. This you can place it here. But before going that, we can simplify it more. Because a square minus x square to the power 1 divided by under root a square minus x square. Under root a square minus x square is a square minus x square to the power half. You already know that. So this base is same. So this half will go up. So it will be like x to the power 1 into x to the power negative half. So it will be x to the power half like that. So it will be under root x. And what is x? Under root, this is a square minus x square. So you'll get a square minus x square and to the power half, and this half is nothing but under root, which I told you in the beginning. So under root a square minus x square can be written in this place. Alright. So you have minus, and then you can write this. There is an integration also, right? A square minus x square under root a square minus x square. Let me write it like this. Then we have this a square by under root a square minus x square. So a square you can take common. So plus a square you just take outside. And after this integration you have 1 divided by under root a square minus x square. Now we have a direct result. See, there are two things which need explanation here. First is under root a square minus x square is the actual term from where we started. It is I only. From here only we started. So you can just replace under root a square minus x square integral as just I. So just write x under root a square minus x square. In this place you just write I, and I is on the left side also, and plus a square. Now this one I was telling you that 1 by under root a square minus x square is nothing but sine inverse x by a. It's just sine inverse x by a. You just write sine inverse x by a here. Sine inverse x by a. Okay, this negative I can be taken on the left. So I minus I, that is actually I minus I, when you take negative on the left hand side, it is I plus I. So it will be twice I. So 2I will be equal to, now I have already taken this out. So x under root a square minus x square plus a square sine inverse x by a. Now we have a 2 on the left hand side. So just take these 2 downstairs on the right hand side. So we have x by 2 under root a square minus x square plus a square by 2 sine inverse x by a, which is the second term of the result which I showed you earlier, plus a constant of integration. So this is your final result and proof of this expression or result. Now this under root x square plus a square dx is equal to x by 2 under root x square plus a square by 2. Then we have a log x plus under root x square plus a square plus a constant of integration. Now from where this formula has come, or from where this result has come, we need to prove it. We need to show the examiner or the person that okay, this is how it has come. So let's solve it first and give you the proof. So we have this I, we are calling it as I, and this is equal to under root x square plus a square integration. Now you can write it as a square plus x square and x square plus a square interchangeably because they both are same. So we'll do it by parts. That is, we assume that is 1 is multiplied here and dx is already there because we are integrating. What is the first function? The first function will take it as under root a square plus x square, and the second function will take it as 1. Now when you have two functions and you want to integrate this, we apply a certain formula, or as a result u integration of v dx minus integration of differentiation of first function, integration of again the second function, and that differential and integral will be multiplied and then it will be integrated again. So this will come outside because this is the first function, a square plus x square. Then we have the integral of what? 1 dx. Then minus integration. Then the differentiation of the first function, which is under root a square plus x square. Then after this, integration of 1 dx again. That is the one which we are doing for the parts. And we assume that 1 is multiplied there. And then again the integration. So this 1 dx will simply give you x. Under root a square plus x square is here. It remains unchanged. Minus. Now integration of what? 1 dx is going to be x only. Let's call it x. Here only. Because I am going to replace it. Now d by dx of under root a square plus x square can be done separately because you know d by dx of under root x is 1 by twice under root x. So if you assume this under root a square plus x square as under root x, it will be simply 1 by twice of under root x. So under root a square plus x square I have written. Now you don't have to stop here. You have to differentiate a square plus x square also. Now what is the differentiation of a square plus x square? A square will be 0 and x square will be 2x. 2 you can cancel now. So this will give you, I am not writing x right now, just writing the denominator a square plus x square under root. Now why I am not writing x? Because integration of 1 dx already gave us x. We got a x from here also. X into x will be x square. That can be written. And then the integration with respect to dx. First part is already done. Now we need to concentrate on the second part, which is x square by under root a square plus x square. So x square is here in the numerator. A square plus x square is in the denominator with under root. Alright. Now I need this a square plus x square upstairs. So just add a square and subtract a square. When you add and subtract a square, what are you going to get? A square plus x square, you can separate it out. But remember, there is an under root in the denominator. So a square plus x square by under root a square plus x square. This is under root and this is also under root. Then minus a square divided by under root a square plus x square. We have separated these two terms and we will integrate them separately in a different way. Means in a different terms. So you know that x divided by under root x, it can be written as what? X to the power 1 by x to the power half. It goes upstairs. X and x 1 and minus half will give you half only. So x to the power half, that is under root x only. So you'll get under root x in this case. So you can just write under root a square plus x square and integral of this one. Now if you take a square outside, only 1 by under root a square plus x square will be in the denominator, that you already know. So this whole is like this. Okay. Now before we go ahead, this negative, let's multiply this in the separate terms which I showed you. I am making it negative and this is as positive. So we have dealt anything which is outside this x under root a square plus x square, which is coming after that. Okay. So we have this negative under root a square plus x square integration first, and then the second term is plus a square we have already taken out, and integration of 1 by under root a square plus x square or x square plus a square, you can write any of these. Now what do you see here? This under root a square plus x square integral is what we have started. This is I only. And what about this one, a square? Let's write the first term first, then I'll tell you about the last one. X under root a square plus x square is already there. Minus I will take on the left hand side. A square is outside. 1 by under root a square plus x square has a direct result. Now let me write it here. And I am writing it here just to keep this thing inside your mind. Like it is log modulus of x plus under root x square plus a square. So in place of integration 1 by under root a square plus x square, just write this log x plus under root x square plus a square. So let me write it here. Log modulus x plus under root x square plus a square or a square plus x square, and better is to keep it inside the bracket after log actually. Now this negative I goes on the left, I minus I, that is I plus I will become. So I plus I will become what? Twice I. Just write 2i here. On the right it will be x under root a square plus x square, and the second term is what? See, just try to coincide with that actual result. So a square log and bracket I am changing now, x plus under root a square plus x square as the second term. Now these two I am bringing downstairs on the right hand side. Now you see this is the result. How easy it was? Under root x square minus a square dx. This is equal to x by 2 under root x square minus a square by 2 log modulus inside this bracket x plus under root x square minus a square. Now what is the proof? How did we get or arrive at this result? Now we are going to prove it for you. So before we go ahead, there are certain things. Integration of u dot v, that is u is the first function, v is the second function. When you integrate this, what is the result? The first function will take as it is. If you assume u and v are the first and second function respectively, u integration of v dx minus integration or differentiation of the first function, which is d by dx of u, and then the integration of v dx. When all of this is done, this will be integrated again. Okay. So this I will be equal to integration of under root x square minus a square. Now the problem is how we are going to go about it. We'll do it by parts. That is, we'll assume that it is multiplied by 1. We don't have to assume, it is already there. 1 is multiplied by every term. And then what is the first function and the second function? So let's take I as the first function as u and the second function as v. So I'm applying this formula now. Under root x square minus a square. Then we have integration of 1 dx minus integration of d by dx of what? Under root x square minus a square, and then integration of 1 into dx, and then after this we will have the final integration. So what are we going to get here? 1 into dx will give you x, and then x square minus a square is unchanged. d by dx of under root a square, x square minus a square, I'll just tell you now. 1 dx will give you x. So let me write it here. I'll just combine it with d by dx of under root x square minus a square. So remember, this is 1 dx is x. Now this is very important. So I'll just do it in a side. D by dx of under root x is 1 by twice under root x. When you differentiate d by dx under root x square minus a square, it is going to give you 1 by twice of under root x square minus a square. That is very well known to you because you have done already the differentiation part. So d by dx of under root x square minus a square, as I told you, d by dx of under root x is 1 by twice under root x. So d by dx of under root x square minus a square is 1 by twice under root x square minus a square. And then we have to differentiate x square minus a square. That will give you 2x. So now this is 2x divided by 2 under root x square minus a square. I am cancelling 2. So you have x by under root x square minus a square as the differentiation. So I'm not writing x upstairs. I'm just writing under root x square minus a square because x is what we got from here. But x was earlier integration 1 dx, if you remember. I told you. So this x and x combined multiplied will give you x square dx. Now I'm going to show you this integration of the second part separately. So it's x square by under root x square minus a square. We need x square minus a square upstairs. For that, you have to add negative a square, subtract negative a square. So just subtract a square and then you have to add also because you are doing it by yourself. Now separate these two terms out. X square minus a square divided by under root x square minus a square will be the first term because we are separating these two terms. And then we have a square divided by under root x square minus a square. I am taking a square outside the integral side. So 1 by under root x square minus a square remains inside. So this simply can be explained by x by under root x. This will give you what? It will give you under root x only. Because it is x to the power half, x to the power half in the denominator, it goes up. It will be negative half. 1 minus half is half only. And anything to the power half is just root. It's just root x. So just making similarity or analogy, it's simply under root x, which is under root x square minus a square in this case. So x square minus a square comes here. Now a square comes outside. 1 by under root x square minus a square is already lying there. Okay. Now negative is already there. So multiply negative here. So both the terms is going to get negative. So we have dealt anything which is coming outside or after x under root x square minus a square. So let's write x square under root x square minus a square. Then you have negative under root x square minus a square. Then you have minus a square outside 1 by under root x square minus a square. Already then. Now you see there is already an I in between. This is I only. Okay, from where we started, this is I only. So we can just replace the middle term by I. And this one x under root x square minus a square remains unchanged. And this is negative a square, but there is a direct result for integration of 1 by square root of x square minus a square. What is the result? I am writing the direct formula. It's log modulus of x plus under root x square minus a square. Now let me write it again because my writing is very good as you see here. So log modulus x plus under root x square minus a square. This is the result. Now this negative I can be taken on the left. It will give you I plus I. And I plus I is going to give you twice I. An I for an I. Who told me this line? Tell me. Okay, now this is 2I. I'm not writing 2 because I'm going to take it downstairs. So let me write other things. X under root x square minus a square. I is already done. Minus a square log modulus of x plus root x square minus a square inside the modulus. Don't forget to write the modulus. Now this already had a 2. So I'm bringing it downstairs on the right. So it's 2 in the denominator plus a constant of integration. From here to here, that's your final result. This question we are going to take in the next discussion. Till then, thank you so much. Have a good one.